If there's something that's probably going to trip you up in any math course, it'll be the notation and not understanding what it is. So you really need to take your time, and when new notation is introduced, you need to really look at it and see what it all means. Okay. So here we're going to take a look at the delta x notation, and we're going to discuss how we can, with a little bit of help from the absolute value function, how we can make that um, into a formula or into some notation for talking about distance. So I want you to go ahead and remember that the distance between any two objects should be a non-negative value. Well, what do we mean by non-negative? Because that gets thrown around a lot. Well, non-negative just means, let me, there we go. Um, non-negative means that the values for the distance must be at least 0. We don't say they're positive because 0 is not positive, and a distance could be 0, but we say that they're non-negative. So if we take a look at a number line here, and let's consider x on this number line, let's say x2 falls to the left of x1. So our delta x here, as we look, our delta x goes from 7 to 3, which is negative 4. But negative 4 is not a distance. And so, although it looks like we've moved negative 4, when we have moved negative 4, the total distance is positive 4. So all we have to do to fix or to remedy this situation is just take the absolute value of that number. Okay, so if we take the absolute value of delta x, which is x2 minus x1, okay, then we'll get the right value here. Oops, I got to reverse the order there. I got this in the wrong order. Now you could take x2 minus x1 or x1 minus x2. It doesn't matter. The absolute values are the same. So the absolute value of x2 minus x1 is the same as the absolute value of x1 minus x2. So now we can use that absolute value of delta x to consider any type of distance between two different x values.